CPU explained, the machine that turns human ideas into digital reality. Every time you tap a screen, type a message, or click a button, a silent chain of events begins. A signal travels through microscopic pathways, millions of tiny electrical decisions happen, instructions move from one place to another. And within a fraction of a second, your device responds. But what happens between your action and the final result? How does a machine understand what you want? How does it know which command to follow? How can a small electronic device perform tasks that would take humans years to complete? The answer is hidden inside a powerful piece of technology built from billions of microscopic switches. The CPU, the central processing unit. It is the component responsible for transforming instructions into actions and turning human commands into digital experiences. From smartphones and gaming computers to airplanes, robots, and spacecraft, the CPU is at the center of modern technology. But to understand its true power, we need to look inside this remarkable machine. The heart of computer decision-making. A computer is made up of many different parts. There is memory that stores information, storage that keeps files, a graphics processor that creates images, input devices that allow humans to communicate with machines. But none of these parts can operate effectively without instructions. The CPU provides those instructions. It acts as the decision-maker that controls the flow of information throughout the system. Every application you open, every command you send, and every calculation your device performs depends on the CPU. Without it, a computer would have all the parts but no direction. What is a CPU? CPU stands for Central Processing Unit. The word central means it plays a key role in controlling computer operations. Processing means it handles information and performs tasks. Unit refers to it being a single electronic component. Simply explained, a CPU is a chip that receives instructions, analyzes them, and executes actions. When you watch a video, play a game, edit a document, or browse the internet, the CPU is constantly working behind the scenes. The speed beyond human imagination. One of the most incredible things about CPUs is their speed. A human may need time to solve a mathematical problem. A CPU can perform billions of instructions every second. Imagine trying to count from 1 to 1 billion without stopping. It would take years. Yet a modern processor can handle enormous amounts of information almost instantly. This extraordinary speed is what allows computers to perform complex tasks in real time. Inside the CPU, a team of specialists. Although a CPU looks like a small chip, it contains several important sections working together. The control unit. The control unit is the organizer of the CPU. It manages the entire operation by deciding which instruction comes next, where information should go, which parts of the computer should respond. It keeps everything synchronized and ensures that every process happens correctly. The arithmetic logic unit. The arithmetic logic unit, also known as the ALU, is responsible for calculations and logical decisions. It handles operations such as addition, subtraction, multiplication, division, comparisons. Every time your computer makes a calculation, the ALU plays a role. Registers. Registers are extremely fast storage locations inside the CPU. They work like a personal workspace where the processor keeps important information it needs immediately. Because they are located inside the CPU, they allow instructions to be processed much faster. The 3 steps behind every computer action. Every command you give your computer follows a process called the fetch, decode, execute cycle. First, the CPU performs the fetch step. It retrieves an instruction from memory. For example, open the web browser. Next comes decode. The CPU interprets the instruction and understands what needs to happen. Finally, execute. The CPU carries out the command. The browser opens, and you see the result. This cycle happens billions of times every second, powering every digital experience. How CPUs learn to handle more. Early processors had only one core. That meant one processing unit handling tasks one at a time. But engineers improved the design. Instead of one worker, they created multiple workers inside a single chip. These are called cores. Modern processors can have 2 cores, 0.4 cores, 0.6 cores, 0.8 cores, and even more. Multiple cores allow computers to handle many tasks at the same time. This is why modern devices can run multiple applications smoothly. Clock speed, the processor's beat. Every CPU has a speed measurement called clock speed. It is measured in gigahertz. Clock speed represents how many cycles a processor completes per second. A higher clock speed can improve performance. However, speed is not everything. Efficiency, architecture, and the number of cores also determine how powerful a CPU is. Why the CPU controls the future. Today, CPUs are used everywhere. Gamers rely on them for realistic experiences, creators use them for editing and design, engineers use them for simulations, scientists use them for research, artificial intelligence systems depend on them for complex processing. The CPU is one of the most important foundations of modern technology. The next generation of processors. The future of CPUs is moving towards smaller, faster, and more efficient designs. Engineers are developing chips that handle more power while using less energy. These improvements will support future technologies like artificial intelligence, robotics, smart cities, and space exploration. The next generation of innovation depends on what happens inside these tiny chips. Final thought. The CPU is not just a piece of hardware. It is the bridge between human imagination and digital reality. Every command you give, every application you use, every technology you experience, all of it depends on billions of tiny operations happening inside a processor you may never see. A small chip. A massive responsibility. The CPU is the reason our ideas can become actions in the digital world. Thanks for watching. In the next video, we'll explore RAM and discover why computers need memory to think and work efficiently.